As we've seen this week, severe weather can linger into September, and tonight meteorologist Casey Dorn shows us the science behind hail and updrafts with an experiment you can try at home.
Welcome back to the Climate Classroom. I'm meteorologist Casey Dorn. In our last experiment, we explored how hail grows through the collision of very cold droplets of water. Today, let's talk about how strong an updraft needs to be to hold these chunks of ice in the air for different sizes of hail. For today's experiment, you'll need a large clear plastic tub or container, 2 beakers or drinking glasses, a ping pong ball, a golf ball, a hairdryer, and some red food dye. This experiment has 2 parts. First, we'll demonstrate how updrafts work, and then we'll talk about intensity. So, grab your container and fill it with cold water. Next, grab a glass, fill it with hot water, and then add 10 drops of red food dye. And then stir that until mixed. Next, take your glass and put it into the cold water and watch what happens. What you just observed was an updraft. Hot water is less dense than cold water, so it rises. In the atmosphere, hot air is also less dense than cold air, so it rises as well. Now let's repeat the experiment with room temperature water in your other glass. Now the temperature contrast is lower in this example, so the water rises much more slowly. For part 2, you're going to grab your ping pong and golf balls and your hairdryer. Notice that the golf ball is much heavier than the ping pong ball, even though they are almost the same size. Grab your hairdryer and turn it on to its lowest settings, and put the ping pong ball above it. All right, now we're going to do the same thing with the golf ball. So, as you can see, at least in this example, the updraft speed of this hairdryer is not strong enough to lift up the golf ball, but in certain thunderstorms, it is. So the stronger an updraft is, the heavier the objects it can hold, and therefore the bigger the hail that you can get. We measure hail based on its diameter. Anything above an inch, the size of a quarter, is capable of doing damage to you and your property, so that's the cutoff for a severe thunderstorm warning. It takes an incredible amount of energy and temperature differences to create an updraft that strong, and that's why we tend to see our strongest storms in the middle of summer when the ground is hottest. See you back in the classroom next week. Meteorologist Casey Dorn, News 5.